So this is an important question that you have to know before you write your exam. And it's saying figure B1.1 below shows a simple pendulum suspended from a fixed point. So a different instrument that you can use to measure time. An example is the simple pendulum. We also have the clock, the stopwatch, and so on. So the way we measure time using the simple pendulum is just very simple. We just need to follow the movement of the simple pendulum. Usually the way it's supposed to be is supposed to be like this. So this is a simple pendulum. It can move from the resting point. So this is the resting point. So when you move it to this side here, maybe it can be somewhere at this point here. Okay, then you let go it will go on this direction here like this. So you find that it is going to reach at a certain point where we can just say this one is going to be where it is going to reach, which is going to be the displacement. So in terms of the movement, the way it is going to move, we can say if we start counting from this point, let me just label this one as A, and this is going to be B, and this one is going to be C. So in terms of the way you're going to count as one number of oscillation, we have what we call number of oscillation, which is N. So number of oscillation, let me just write it like this. Okay, number of oscillation, which is represented by small letter n. So the way you are going to count the number of oscillation is just very simple. You have to count the number of swings that this one is moving from this position and up to this position and come back to the same position. So for example, if the bob, mind you, this one is the bob, if it starts from A, it will move through B up to C and then back to the same position, which is A. That's when it is going to make one number of oscillation, which is 1. N is going to be equal to 1. Then again, when it moves from A through B to C and back to A, it is going to make 2 swings or 2 number of oscillations. That is one thing that you have to understand. Now, where is that one coming from? Let me explain. The way we deal with this one here is just very simple. One thing that you have to understand is that for the bob to come at point A, it has to move 4 steps. So we're going to use probability here. So from A to B, that is the first movement. From B to C, that is the second movement. Remember, for it to complete one oscillation, it has to move from A through B to C and back to A. So again, it is going to take the same path, that is from C to B, that is going to be 3 movements. Then from B to A, that is 4 movements. So it just depends on the movements that this bob has taken. Okay, so if the bob has moved from A to B, meaning to say it haven't completed one oscillation. So if you want to find the number of oscillation, what are you supposed to do? You have to say number of oscillation is going to be equal to you say favorable outcomes divided by the total probability. So in this case, the total probability is 4. Favorable outcomes, the movement of the bob. Is it from A to B, or is it from A through B up to C? So if it is ending at B, so meaning you're going to put 1 here on top. If it is ending at C, how many movements? 1, 2. So you're going to put a 2 on top. If the question is saying the bob moved from A through B to C and back to B, meaning how many movements? See, that is 1, 2, 3. So meaning you're going to put a 3 on top here, and then you divide. Then you're going to find maybe 0.75. Okay, that is one thing that you need to understand. Then again, there are also some things that are very, very important to understand here, like the amplitude, as well as the amplitude is just the angle. And then also the mass of the pendulum, acceleration due to gravity. So there are factors that affect the period of the pendulum and factors that does not affect the period of the pendulum. So let me start with the factors that does not affect the period of the pendulum. Number one is mass, followed by the amplitude, which is the angle. Okay, so these two things, they don't affect the period of the pendulum. But when it comes to the acceleration due to gravity, it affects the period of the pendulum. The length of the string, it affects the period of the pendulum, in that when you shorten the length of the string, you're going to find that you're going to make many number of oscillations, but when it comes to the frequency is going to be lowered. When you increase the length, the frequency is going to increase, but the number of oscillations is going to reduce. So it's just very simple to understand. So the bob is slightly pulled to position A, then released. State one factor that does not affect the period of the pendulum. So here you can just say mass of the bob. Mass of the bob. If you don't want to say the mass of the bob, you can say the amplitude. Then question B, if the values of time for 20 oscillations obtained were 16.1, 15.9, 16, 16.2 and 15.8, calculate the period of the pendulum. So this is the time taken. So these were just like the survey which they undertook for them to obtain 20 oscillations. So what we need to do here, we have to find the average here. So how many are they? 1, 2, 3, 4, 5. So I have to add them, then divided by 5. So 5 is coming from the number of them. So if here we just have 2, where we can say 1, 2, I just need to add this one and then divide by 2. So let's add. So you have to show all your working here. So I'm adding here, then 16.2 plus 15.8, then divided by 5. So on top I'm going to get 8, then divided by 5, then when I divide I'm going to get 16 seconds. So this 16 seconds, you can also obtain it from here, where you say the average is the number which is at the middle. So which number here is at the middle? So if you divide these to say, I can group this into 2, then this one into 2, then this one is going to be at the middle. So the average is the number at the middle. So this is the time, or the average time that we are looking for. So let's calculate the period of the pendulum. Period of the pendulum is equal to the time taken divided by the number of oscillation. Okay. So in this case, let me just confirm that one. Okay, so the time taken, which is 16, then divided by the number of oscillation, which are 20. So 16 divided by 20, then I'm going to get 0.8. So this 0.8, it has to be in seconds, because period of the pendulum is more like time, so it is measured in seconds. For the frequency is equal to 1 over the period of the pendulum. So in this case, it's 1 divided by 0.8. So 1 divided by 0.8, I'm going to have 1.25. So frequency is measured in Hertz. Then from there, we are done. So this is how you're supposed to answer this question